Hello, guys. You're welcome to today's teaching. I believe you guys are doing very, very fine. If you are just watching this YouTube channel for the very first time, kindly subscribe to this YouTube channel. This is the one. This is one of the best YouTube channel as far as chemistry content is concerned. So if you are just watching this YouTube channel, kindly subscribe to the channel and turn on the notification bell so that you know when I upload any video, you are going to be notified. Very quickly today, I'm going to take a concept. I want you guys to pay maximum attention because I've seen a lot of misconception about this very particular topic, and I'm going to teach that, trying to simplify it today. So pay maximum attention. So today we are going to be considering laws. We're going to be considering laws of chemical chemical, combination. Very important law in chemistry because this law governs a lot of chemical reactions in chemistry. So today we are going to be talking about law of chemical combination. If you would agree with me that for every chemical reaction, there is something we call reactant. Okay, for every chemical reaction, there is something we call reactant, and these reactants will react together to give us what we call products. I hope this is clear. They will react together to give us what we call product. Now, for this very particular reactant to come to product, there are laws that govern this very particular combination. There are laws that governs the process whereby your reactants come together and they form your product. So, and this very particular law, the law, let me write them so you get to understand. The law, the law, okay, the law of chemical combination, the law of chemical combination, the law of chemical combination are are those laws. Law of chemical combination are those laws that govern, okay, that govern those laws that govern the changes, okay, the changes from reactant, the changes from reactant to products, from reactant to products, involving the mass, involving the mass, okay, involving the mass, the volume, the mole concept. I'm still going to do a topic on that, don't worry. I'm still going to do a video on that. Mole concept is one of the topic that a lot of subscribers has actually, called me to actually make a video on it. So I'm going to do that. And relationships, right? So this law of chemical combination are the law that governs the changes from reactant to product involving the mass, the volume, the mole concept, and the relationship between them. So I've said earlier that before your reactant will change to product, which involving their mass, their volume, their mole concept, and a lot of things like that, there are laws that govern them. And what are these laws? What are these laws? Number one, we have what we call the law of conservation. The law of conservation of mass or matter. Law of conservation of mass or matter. Okay? Law of conservation of mass or matter. Number two, we have law of definite, people call it definite, okay? People call it constant, it's still the same thing, or fixed proportion, still the same. So we have law of conservation of mass or matter, we have law of definite, constant, or fixed proportion. We have three, law of multiple proportion. We have law of multiple proportion. We have law of multiple proportion. Then four, we have number four, we have law of reciprocal. We have law of reciprocal proportion. So we are going to be looking extensively, how all these things works. So don't forget the law of chemical combination. We have law of conservation of mass or matter. We have law of definite or constant or fixed proportion. We have law of multiple proportion. Then we have law of reciprocal proportion. What are the applications of these laws? Very important. What are the applications of this law? What are the applications of this law? How do we use this law? What are their relevance in chemical reaction? How do they work? So I'm going to take two in this very particular video so that it will not be very long. Then I'll do another video to explain the number 3 and the number 4. So in this video, I'm going to be explaining law of conservation of mass or matter and the application. And I'm going to be explaining law of definite or constant or fixed proportion. So I'm going to make another video where I'll be explaining law of multiple proportion and I'll be explaining law of reciprocal proportion. So you have to subscribe to this channel and you have to turn on the notification bell so that when I upload all those videos, you are going to be notified. So very quickly, let's dive into the law of conservation of mass. Law of conservation. Law of conservation of mass or matter. What's this law saying? Let's state the law, then we'll now take the applications of the law. I'll take examples so that we can understand. This law is a very familiar law. This law states that, this law states that, this law states that matter is neither created nor destroyed in the course of an ordinary chemical reaction. Okay, I need to state it like this because if in our rudiment chemistry we have talked about the John Dalton atomic theory, and if you remember the John Dalton atomic theory said matter can neither be created nor destroyed, but several modifications were done to it because likes of Henry Bancroft that discovered radioactivity made us understand that matter can be created and can be destroyed when it comes to nuclear reactions. And that's why if you look at you have to pay attention to it. I said in the course of an ordinary chemical reaction. So this very particular law will work for an ordinary chemical reaction because for nuclear reaction, matter can be created and matter can be destroyed. And that's why we have the likes of nuclear fission and nuclear fusion. I hope that is clear. So for ordinary chemical equation like this, law of conservation of mass will hold. But for nuclear reactions, law of conservation of mass might not hold. I hope that is clear. So that's why I said the law states that matter is neither created nor destroyed in the course of an ordinary chemical reaction. So for ordinary chemical reaction, the law of conservation of mass will hold. Let's see examples. And that's the reason why it is this law that brought about the balancing of chemical equations. That's why in chemistry, when we write equations, we will need to balance them. and it is because of the law of what? Of conservation of, mass. So let's see a particular example. Let's take an example. I have a reaction where I have sodium chloride. I have a reaction where I have sodium chloride, the aqueous form, okay, reacting with what? Silver nitrate, okay, the aqueous form too, giving us sodium nitrate in the aqueous form and silver chloride. This is an ordinary chemical reaction. This is a chemical reaction. So how do we know that the law of conservation of mass will hold here? Because for this very particular sodium chloride and HNO3, which is silver nitrate, we call them the reactants. So they reacted together to actually give us this what? This product. I hope this is very clear. They reacted together to actually give us this product. So this is a chemical reaction. So what is the application of law of conservation of mass here? How can I prove in these equations that the law of conservation of mass holds for this very particular reaction? Let's use their atomic weight or the atomic mass like we know. Don't forget that you are always given that anyway in chemistry, that our sodium, they would have given us to be 23. Just an example, our chlorine is always 35.5. Our silver is always 108. Okay, our nitrogen is always 14. What other one do we have? Oxygen too is there, 16. So we want to use their atomic weight to actually prove that the law of conservation of mass will hold. So for sodium chloride, what are we going to have? It's going to be the first compound is sodium chloride. So we are going to have 23. Okay, we are going to have 23 plus chlorine, that's 35.5. Then plus, that's on the reactant side, silver, we have 108, okay, plus nitrogen, we have 14 plus 16 times 3. That's for the reactant side. For the product side, we're going to have sodium, that's 23, plus nitrogen, that's 14, plus oxygen, that's 16 times 3. Then plus, we have silver chloride, that's 108 plus 35.5. So let's see. So at 23 plus 35.5, if you use your calculator, you're going to have 58.5, okay, plus 108 plus 14 plus 16 times 3. If you use your calculator, we are going to have 170. Are we together now? Then to the product side, if you use our calculator, 23 plus 14 plus 16 times 3, 16 times 3, that's 48. If we add 48 to 14 and 23, we're going to have 85, okay? Then plus, if we add 108 to 35.5, we are going to have 143.5. I hope this is clear. So let's add all the masses on the reactant side together. That's the 58.5 plus the 170. We are going to have the calculator 58.5 plus 170. We're going to have 228.5. Then the product side, adding 85 to 143.5, we are going to have what? 228 also 0.5. Can you see that? So which means the masses on the reactant side is equal to the masses on the what? On the product side, which means nothing has been destroyed. Everything we are seeing here is just like you are rearranging the elements. We are rearranging the elements, and that's why the law states that nothing is destroyed, nothing is created. The mass on the left hand side. So the meaning of the law is that the mass on the left hand side and the mass on the right hand side must be the same for an ordinary chemical reaction for the law of conservation of mass to hold. I hope this is clear. I hope this is clear. So for everything you have on the reactant side, it must be equal to everything you have on the product side. And if this is so, it means that the law of conservation of mass will what? Will hold or hold for that very particular reaction. And that's the reason why, very important, this is the reason why in chemistry we have to balance equations. Yeah, in chemistry, we have to balance equations. And why do we need to balance equations under the chemical reaction? So that the law of conservation of mass will hold. Let me do a simpler one, then I'll do another one, then I'll move to the next law. Example 2, let me do a familiar one. Just like we are having hydrogen, okay, reacting with oxygen. Can you see that? Then giving us water, okay, then this. If you look at this equation, it is not balanced. Can you see that? So it is the law of conservation of mass that prompted balancing of equation. Because for law of conservation of mass to hold, it means that the equation has to be balanced. So the law of conservation of mass will not hold like this because the equation is not balanced. So I have to balance this equation. So how do I balance it? You know, I can add my two. I've done that on this channel, balancing of equation. Then I'll put 2 here too. So hydrogen now is now 4, hydrogen here is now 4, oxygen here is 2, oxygen here is what? Is 2. So from here now we can now see if law of conservation of mass will hold. So here we are going to have 2 into the atomic mass of hydrogen is 1 times 2, okay, plus oxygen is 16 times 2, then going to 2 into bracket 1 times 2 also plus 16. I hope this is clear. So from here we have 2 into bracket 2 plus 32, okay, going to 2 into 1 times 2, that's 2 plus 6, that's 18, okay. So this becomes 4, 4 plus 32, that gives us 36, then 2 times 18, that will give us 36. So law of conservation of mass holds also. I want to believe that this is clear. Okay, so law of conservation of mass is telling us that matter can neither be created or mass can neither be created nor destroyed in an ordinary chemical reaction, meaning everything we have on the reactant side must be equal to everything we have on the product side. I want to believe that is very clear. So in an ordinary chemical reaction, if the reactant comes together to give us product, even if they are gases, everything on the right hand side must be equal to everything on the right hand side, which implies that everything on the right hand side must be equal to everything on the product side. Let me give this example. You can have a question like this. Example 3, you can have a question like this. You know, a more technical question like this. That calculates. Look at this question. Calculate the mass. Calculate the mass of silver chloride. Calculate the mass of silver chloride precipitate formed. Okay, calculate the mass of silver chloride precipitate formed when 10.10 gram of silver trioxonitrate, 5 reacts with 14.10 gram of sodium chloride, okay, of sodium chloride to form 9.58 gram of sodium trioxonitrate 5. Look at this question. A lot of students will see this question and say, no, this is not the kind of law of conservation of mass I am used to. Okay, they'll be like, no, this is not the kind of law of conservation of mass I am used to. And they begin to get themselves confused. But you just have to know all these things. You have to know all these things because this one is testing your knowledge of, do you know how to name compounds? Do you know how to write their molecular formula? This is basically what this question is testing. So, and that's the reason why if you have not watched the video on my channel, I have dropped all this video. Dropped how to balance equation. I've dropped how to name inorganic compounds. I've done how to write the molecular formula of compounds when they are given in words like this. So You can see all these things are just interwoven. So you have to. So let's see. Calculate the mass of silver chloride precipitate formed when we need to get the reactant in the question. When 10.10 gram of silver triazonitrate. So that's the reactant. They said we should calculate the mass of silver chloride precipitate form when 10.10 gram of silver triazonitrate react with. So we have to write that silver triazonitrate is written as AgNO3. Can you see that's very important? That will be in the aqueous form plus react with what? 14.10 gram of sodium chloride. So you should be able to write sodium chloride. So this sodium chloride also in the aqueous form. Going to what? Then also calculate the mass of silver chloride precipitate. Can you see? When 10.10 gram of silver triazonitrate reacts with 14.10 gram of silver chloride to form, that's the product, to form what? So to form sodium triazonitrate 5, okay, sodium triazonitrate 5, that's NaNO3. I hope that is clear. That's aqueous. Then plus, because they asked us to calculate the mass of silver chloride, definitely that will now be on the product side too. So silver chloride will be AgCl. That will be solid. So let's check the question if it is balanced. 1 Ag here, 1 Ag here too. Balance 1 Ag here, 1 Ag there. Balance, okay. Here we have 1 nitrogen here. Can you see? 1 nitrogen here, 1 nitrogen here too. Can you see? 1 nitrogen here too. Balance, okay. 3 oxygen here. Can you see? 3 oxygen here. Then we have another 3 oxygen here too. That's balanced. Then we have 1 sodium. We have 1 sodium. So the equation is balanced. If the equation is not balanced, you have to balance it. So now they have given us the mass that is reacting. So let's go straight to that. They said calculate the mass of silver chloride precipitate formed when 10.10 gram of silver triazonitrate. So this one is 10.10 gram. Okay, plus silver chloride. Did they give us the mass? They gave us, okay, 14.10 gram. They gave us that. Going to, did they give us the one for sodium triazonitrate? Is given in the question. Good. That's 9.58, right? The question is now calculate the mass of silver chloride. So this will be X. This is what we are looking for. From our law of conservation of mass, we already know that everything on the reactant side will be equal to everything on the product side. So we can add 10.10 gram plus 14.10 gram. Okay, if we add that, that's going to give us what? 24. If we add this, that's give us 24.20. I want to believe that is equal to, because everything on the reactant side must be equal to everything on the product side. That will now be 9.58 plus what? X. Can we see that now? So take this 9.58 to the other side, it becomes minus. So we can now have our X to become 24.20 minus 9.58. And our X is going to be what? The mass of silver chloride now is going to be what now? So if we do that subtraction, we're going to have 14.62 gram. Can we see that now? Why am I able to solve this? Because I know everything on the right hand side must be equal to everything on the left hand side. I will equate it, then I'll look for it. So the mass of silver chloride precipitate is equal to what? 14.62 gram. 14.62 gram. And that solves the question. I want to believe that's clear. So you can be given questions like this. You can be given questions like this. I've done 3 examples. So go over the video over and over and over again so that you can understand. So let's move to the next one. I want to believe this is clear. So let's move to the second one now, which is the law. The second one now, the number 2, which is the law of definite. Okay, law of definite. Some textbook will tell you is fixed. Okay, anyone, some will tell you is constant. We are still saying the same thing. So law, anyone they are using is still the same thing. And I want us to pay attention to this one too. I want to pay attention. I want us to pay attention to this. Please pay maximum attention to this. Before I actually solve some questions here and explain the application of this very particular law. What does this law state? What's this law? Let's state it. So very important, you must be able to state it. Yes, you must be able to state it. It's very, very important. So the law states that all pure, all pure samples, all pure samples of same chemical compound, all pure samples of same chemical compound, all pure samples of same chemical compound contain the same element, contain the same element, okay, combined, contain the same element combined in the same proportion by mass. I love this law. In the same proportion by mass. Same proportion by mass. So, what is this law stating? What's the meaning of this thing we have stated? I want us to take some keywords from this definition. All pure samples, can you see that? Pure samples of the same chemical compound, these are keywords. Chemical compound contain the same element, these are keywords, combined in same proportion by mass. Wow, these are the keywords. 4 keywords, very important. All pure samples, this is a keyword. All pure sample of same chemical compound, okay, this is another keyword. Contain same element, this is another keyword, okay. Combine in same proportion by mass, this is another keyword. Okay, so what is the meaning of this law? What is this law saying? Simply put, the law is saying that if a substance is pure, if a substance is pure, no matter the way you have produced it, do you understand? I just want to put it in a simple way. Simply put, if a substance is pure, okay, comma, no matter its source or methods of producing it, its composition is constant. That's the meaning of the law. Its composition is constant. That's the meaning of the law. That's what the law is saying, and I will explain. Now, very, very important. I have done a video on pure and impure samples. It's on the channel, because for all pure substance, we must agree with me that for all pure substance, all elements and all compounds are pure substance. And if something is pure, it's not like the normal name, the way we see pure substance. It's not the normal name way we see pure substance. In chemistry, pure substance have their characteristics, and one is that they have fixed proportion, very, very important, and that's what brought about that law. And number 2, they have one type of molecule or atom. I have done that video. So what is this law saying now? That there is no way you prepare anything that is pure, no matter the way you have prepared it, okay, no matter the way you have prepared it. You get that? Its composition will be constant. Let's take example for the law of fixed proportion. So don't forget I said, simply put, if a substance is pure, no matter its source or method of producing it, its composition is constant. So let's see examples. What do we mean by that? Let's take examples. Okay? Let's take examples. Now, let's take, for example, I want to prepare lead 2 oxide in the laboratory, and I want to use different means. So let's take, for example, that I want to prepare lead 2 oxide. So let me take these examples. Two 2 samples of lead 2 oxide was prepared. So we want to prepare lead 2 oxide in the laboratory. So I prepared it by using, we can prepare it in different ways. One of the method we can use is by direct combination. I'll give example. I'm just trying to, by direct combination, can do by direct combination where I have lead, okay, reacting with oxygen to give me lead 2 oxide. Then I'll balance the equation. Then I'll balance this equation. So I can prepare, this is what I want to prepare. This is a bone of contention. This is what I want to prepare, lead 2 oxide. So I prepared my by direct combination, and you now use this method. You heated, or by heating, you heated lead, you heated lead 2 triazocarbonate, or let me just say lead triazocarbonate. You heated lead triazocarbonate 4, or let me say lead 2, let me be specific, lead 2 triazocarbonate 4. So if we do that, we are going to have something like this. The equation is going to be like this. Then we are going to have the product to be this, okay, and we are going to have it to be these two. I hope this is clear. So where is the bone of contention? So this is what we want to prepare. Okay, so let's see if the equation is balanced. Lead, balance, 3 oxygen, 3 oxygen. Now, please pay attention to this very well. Pay attention to this very well so that you can just get what the law is saying. So we wanted to prepare lead 2 oxide in the laboratory. So I use this first method and you use this second method. Don't forget that this lead 2 oxide is a pure substance. Why? Because it's a compound. All compounds and all elements are pure substance. So in the analysis now, when I was preparing my own, let me have the samples. Let me have samples. Okay? Let me have samples. So don't forget that mine is sample 1. So let's have my own as sample 1 and your own as sample 2. Please pay attention to this. So mine is sample 1, your is what? Is sample 2. So I can have, what is, they now we gave the mass of the PbO we got. That's the lead 2 oxide. For mine, I got 11.00 gram. For yours, you got 4.00 gram. Okay. And our lead, because in lead oxide, definitely you have 2 elements, that is lead and oxygen. So let's have the mass of lead and the mass of oxygen. So the mass of lead there, let's assume here is 3.00 gram. Okay, let's assume here is 1.20 gram. Okay, so if the mass of, please pay attention to this. So these are the values they gave us. The mass of lead oxide is 11 gram in the first sample. The mass of lead 2 oxide is 4.00 gram in the second sample, while the mass of lead is 3 gram and this one is 1.20. See, 1.20 rather. So since this is mass of PbO, right? That's lead 2 oxide, okay? Since this is lead 2 oxide, what do we need to do? We need to subtract this from this to get the mass of oxygen, because the combination of lead and oxygen will give us this lead 2 oxide that we have here. So if we subtract that, we are going to have 8.00 gram here, and if we subtract that, we are going to have 3.20 gram here. Okay, so let's see if this law obeys definite proportion. So let's calculate the percentage. Let's calculate the percentage composition of let's say lead in sample 1. We are familiar with percentage composition, so we should be able to do that. So in sample 1, mass of lead, that's what we are calculating in sample 1. So what's the mass of lead we have? that's 3.00 in the first sample, right? Over what is the total mass of the compound, that's the lead oxide, that's 11.00, and we are looking for percentage composition times 100 over 1. That's how. So if we use our calculator, 3.00 times 100 divide 11, that's going to give us, let me use my calculator. Okay, 3.00 times 100 divide 11. Okay, that's giving me 27, approximately 27.27%. So in the first sample, the mass of lead in the first sample is what? 27.27%. So let me do the percentage composition of oxygen. That's the second element that you have there. Percentage composition of oxygen in sample 1 also. In sample 1. Percentage composition of oxygen in sample 1. So what is the mass of oxygen in sample 1? What's the mass of oxygen in sample 1? Okay, that's 8. This is it. This is the mass of oxygen in sample 1. So we have 8. This is it. You can see that. This is it. 8. Can you see that? So that will be 8.00. What is the total mass of the compound in the first sample? That's 11. Okay, that's 11.00. 10 times 100 over 1. Let's have our calculator again. That means my calculator, 8.00 times 100 divided 11. Okay, that's giving me approximately 72.73%. I hope this is clear. I hope this is very, very clear. Okay, let's move to the second sample now. Let's do same thing for second sample. Percentage composition of lead in sample 2. So in sample 2, what's the mass of lead? That's, so let's do 1.20. This is it. 1.20. Can you see? 1.20 over the total mass. This is it. As 4. Can you see that? 4.00. Then we are looking for percentage composition, so that will be 100 over 1. So let's add that. 1.20 divide, okay, sorry, here is 4.40. Sorry, that's an omission. Second sample is 4.40, not 4. That's an omission. 4.40, please, because 1.20 here plus this will give us this. So that's 4.40 here. 4.40. So from there, that means my calculator now, 1.20 times 100 divide 4.40. That's also giving me 27.27%. Okay, interesting. Then the second one, let's check the second one. We want to calculate for oxygen now. So the second one now, for oxygen, can you see for oxygen in the second sample, we have 3.20. That's for oxygen, right? We have 3.20. So let's do the calculation now. So let's do the calculation. Percentage composition of oxygen. So let's do that. Percentage composition, okay, of oxygen in sample 2. In sample 2. So don't forget, we already talked about that. I already showed us that. That's 3.20, okay, over 4.40 times 100 over 1. So let me use my calculator. 3.20 times 100, okay, divide 4.40. That's also giving me 72.73%. Can you see something now? Look at this. The first sample. Look at oxygen to oxygen. Can you see it? At oxygen, look at oxygen, the same percentage composition. Can you see that now? Look at lead to lead. Can you see that? The same composition. So the law of definite proportion is correct, which means that no matter the way you have prepared it, the proportion by mass will not the same. I know some people are still finding it a bit confusing. I will do more examples so that you understand. I will do more examples. But pay attention to this. And let me quickly talk about that. For law of definite proportion, you need the mass of the elements. Very important. Because from here, if you are given, because we need three, we need three, we need this, we need this, we need this. So if they are giving you these two, you can look for this. Do you understand that? If they are giving you 11 and 3, you can look for this. If they are giving you this and this, you can look for that. And I'll do that in the second example because the question can come in a whole lot of ways. So let me do example 2. And let me use a question, probably a white question, a jump question. Okay, let me use this. Okay, look at this question. I think this is a jump question. So two samples, okay, I think it's white. Two samples of lead 2 sulfide. Look at this question. Two samples of lead 2 sulfide were prepared. Okay, by one, they gave us the method eating a mixture, of lead, solid and sulfur. So let me provide, they didn't actually give the equation, but all these things will help us. I will try and give the equation so that it will help us for people that are actually, it will just help your chemistry knowledge. And when you see it somewhere, you can quickly note that. And the second sample, they said by passing hydrogen sulfide, okay, pass hydrogen sulfide gas into a solution of lead 2 chloride. Okay, so let me just give the equation. You don't actually need that, but just to fortify your chemistry knowledge. So the first one, a mixture of lead solid and sulfur, that can just be direct combination. That's lead plus sulfur. Do you understand that? Eating it and you are going to have lead sulfide. That's the first equation. Sorry, lead sulfide. Let me use my eraser so that you guys will see it very well. Let me erase this and rewrite so that you see it very well. Okay, so let me write that so that you guys will see it very well. So it will not be as if, you understand? So lead sulfide, that's just P. Let me write it very well. Okay, for the sake of people that want all those. So it's equation balance here. So this is the first equation, though you are not giving, but I'm just doing that. So the second equation, passing hydrogen sulfide gas into a solution of lead 2 chloride. So I can have, okay, I can have H2S hydrogen sulfide, that's hydrogen sulfide gas, into what? Lead 2 chloride. I've taught you guys that it's on the channel. How to write all these things on the channel. You need to know all these things, okay? You need to know all these things because some questions they might even want you to write. So and that will give us HCl, okay? Aqueous plus, going to give us lead sulfide. Is the equation balance hydrogen 2, so I can just put 2 here. I want to believe that's clear. The equation should be balanced now. 2 hydrogen here, 2 hydrogen here, balance. Sulfur is 1, sulfur is 1, chlorine is 2, lead is 1, so balance. They didn't actually give the equation of reaction, but I'm just doing that to fortify our chemistry knowledge. So now, they now say analysis. This is where the question comes from. So they now said analysis of both samples, analysis of both samples, that's 1 and 2 and 2 show that show that so for sample 1, the reason why they are giving you all these values is because you are not actually 0.8 gram, you are not actually doing the practical, okay? Because all these things have their practical. So if you are doing the practical, you are supposed to be generating the values yourself based on the practical that you have done. I hope that's clear, but you are not doing the practical. So in a theoretical question, they will give you these values. So it is you that will now use these values to calculate anything they actually want you to calculate. I want to believe this is clear. So in sample 1, they gave us, they said 0.8 gram of sulfur combined with 1.48 gram of lead. While the second sample, they gave us 5.50 gram of lead sulfide. Please pay attention to this. JAMB students, WAEC students, pay attention to this. Contain 2.0 gram of sulfur. If it is WAEC question, they will say use these details to verify particular law. They won't even give you the law. Yes, they might say use this result to illustrate a law in chemistry. So it is you that will now, because they know if they say use this law to illustrate law of constant proportion, you will know what to do. But seeing the question, you should be able to tell if this very particular question is on law of constant proportion, multiple proportion, reciprocal, law of conservation of mass. So if it is JAMB, they might tell you calculate the percentage of lead in the first sample. You can see calculate percentage of this in the second sample. So we are taking all the questions together. Either it is WAEC, either it is JAMB. We are taking everything together so that you understand how to go about it. So very quickly, what you need to do, don't disturb yourself, just come, tell them, okay, let's have the samples. Arranging it will give you, edge to be able to solve. So sample 1, I can say this sample 1, then I will have sample 2. I hope that is clear. So, and what did they say? They say the compound here, don't forget, we need the compound first. That's lead sulfide. And in lead sulfide, lead 2 sulfide, we are going to have lead and what? And sulfur. Very simple. We are going to have lead and sulfur. So in the first sample, they said is 0.8 gram of sulfur. So in the first sample, they gave us 0.8 gram of sulfur. I hope this is clear. Why in the second, and combined with 1.4 gram of lead. So 1.4 gram of lead. That's the information they gave us. Why the second sample, they gave us 5.50 gram of lead sulfide, lead 2 sulfide, okay? And they gave us 2.0 gram of sulfur. You can see 2.0. So what do? We should know, I've explained in the first example that it is this lead and this sulfur that combine together to give you this, right? So if this is 1.4 and this is 0.8, it means I will add the two together to be able to get this. And if I add that together, I'm going to get 2.20, right? 2.20 or 2.2, anyone. Then I can have here, since they gave me for lead sulfide, they gave me for sulfur, they didn't give me for this, so I can subtract these two. That's clear. And that'll give me 3.5, 0. So let me leave it to 2 decimal places. This one will be 0, so that it will be coherent. This one will be gram. Let me leave this one to 0. So the same thing, let me leave this one to 0 gram 2. So that it will be 2. So you can see now we have gotten the values that we need. Look at what they gave us, but we have completed it by getting the value. So let's see the percent. They might ask you for JAMB, calculate the percentage composition of this in the first sample, but we'll do everything so let's do percentage. Let's do percentage composition of lead in sample 1. Percentage composition of lead in sample 1. So what do? We take for lead 1.40, so that'll be 1.40, right? Over the total mass, that's 2.20. We are looking for percentage composition times 100 over 1. So my calculator, 1.40, let me use my calculator now. 1.40 times 100, okay, divide 2.20, that's giving me 63.63%. For percentage composition of lead in sample 1. I hope this is clear. So percentage composition of lead in sample 1 is giving me this. So let me see percentage composition of oxygen in sample 1 also. So can know we are done with sample 1. Percentage composition of oxygen in sample 1. So percentage composition of sulfur, rather, sulfur, not oxygen, sulfur, in sample 1. So let's see percentage composition of sulfur in sample 1. That give us sulfur here is what? Is 0.80. So we have 0.80 over the total mass 2.20 times 100 over 1. So 0.80 times 100 divided 2.20, that's giving me 36.37%. Okay, so for sample 1, we are done with sample 1. So let's move to sample 2 now. So we can have percentage composition of lead, that's Pb, in sample 2. So in sample 2, what is lead? In sample 2, what is the percentage of lead? That's 3.50. Can you see it? 3.50. So we have 3.50. Have 3.50 over what is the total mass? This is it, 5.50 times 100 over 1. So 3.50 divide 5.50. Okay, let me do 3.50 my calculator times 100, then divide 5.50. What's it giving me? Interesting. 63.63%. Can you see that now? Why? Let's do for oxygen. Percentage composition of oxygen in sample. Sorry, why do I like oxygen like this? Maybe because I breathe in oxygen. So sulfur, we are calculating for sulfur. Maybe because I breathe in oxygen, so I love oxygen so much. In sample 2, so percentage composition of sulfur in sample 2, let's go up and see what's the mass of sulfur that we have. Okay, that's 2.20. This is it. This is it, 2.20. Can you see it? 2.20. So we can have 2.20 over the total mass, that's 5.50 times 100 over 1. So we can engage our calculator. 2.20, that's the percentage composition of sulfur in the second sample. So 2.00, not 2.20, 2.00. So this is 0. So 2.00 times 100, okay, that's giving me 200, divide 5.50, that's giving me 36.37%. So look at that. The first sample, look at lead in the first sample, 63.63. Lead in the second sample, 63.63. Okay. Sulfur in the first sample, 36.37. Sulfur in the second sample, 36. So we have used the information given to us. So if it is done, they ask you to calculate any of the percentage composition. Maybe they ask you to calculate for lead in the first sample, 63.63% is what you are going to be choosing in the option. If they ask for sulfur, 36.3% is what you are going to be choosing in the option. But if it is WIAC, they give you those values and they ask you to use it to prove a particular law. Then you use it to prove this, and you tell them it is the law of constant proportion, and probably they will have even asked you to state the law. If it is WIAC that use this very particular information to prove a law, after you have used it to prove a particular law, then they will ask you to state the law, because they know if you prove the wrong law, you will state the wrong law. Can you see that? So that means you would be wrong. So that is that for law, which means that look at all the example we did. We prepare them in different ways, but their proportion by mass is the same. Why? Because they are pure. That's what law of constant proportion is saying. So in as much as they are pure, even if you prepare them in 3, 4, 5 different ways, their proportion is going to the same. So let me give this work to do You can give me the answer in the comment box section. Yes, you can use the comment box section to give me this. So I'm not going to do this. You're going to do this on your own. So let me give this as the assignment. So you can provide me the answer in the comment box section. I want to see what you have gotten in the comment box section to see if you really understood the class. So I have here the assignment is 3 samples. So I'm giving you 3 samples. 3 samples of copper 2, 3 samples of copper 2 oxide was prepared. So you can just do this one yourself and see how much you understood the topic. 3 samples of copper 2 oxide was prepared. The first way we prepared it by adding concentrated trioxonitrate 5. Now this one is just a theoretical question. So if you don't know the equation of reaction, don't worry. It is the values that really matters. Acid and eating. They are just telling you the way they prepared it. That's how they generated those values they wanted to give you by heating the solution formed to dryness. Okay, that's the first way they prepared it. Number 2, they prepared by heating strongly the mixture of copper tetraoxosulfate 6. Okay, solution heating. Okay, let me include heating strongly the mixture of copper tetraoxosulfate 6 solution and sodium hydroxide. While the third one, they prepared it by heating copper trioxocarbonate by heating copper trioxocarbonate 4 to dryness. So they prepared this copper 2 oxide by these 3 ways. That's the way they prepared it, by these 3 ways. They prepared it by these 3 ways. Okay, so the analysis now, okay, this is what you actually need. They're just telling you the way they prepared it. So after doing all this, their analysis of the 3 samples, shows that one 2.25 gram of copper 2 oxide. I want to believe you are getting something from this question now. You should know what to do. Contain 2.01 gram of copper, while in the second sample they said 2.15 gram of copper 2 oxide contain 1.92 gram of copper. That's for the second sample. And for the third sample, they said 2.44 gram of copper 2 oxide, okay, contain 2.1 gram of copper also. So for sample 1, they said 2.25 gram of copper 2 oxide contain 2.01 gram of copper. For the second one, they said 2.15 gram of copper 2 oxide contain 1.92 gram of copper, while the third one they said 2.54 gram of copper. Two oxide contain 2.1 gram. So if it is jam, they can say calculate. If it is jam question, they can say calculate the percentage of copper in the samples, or calculate the percentage composition of oxygen in the sample. If it is jam, they can ask you that. But if it is WAEC, they can say, but if they even say this, you have to still do this, because the question will now say, show that that's the assignment. Show that this result obey law of definite proportion. So if it is WAEC, WAEC can bring it like this. Show that this result obey. So use this, these values we are giving you to show that it obeys law of definite proportion. Or if it is WAEC, they bring like show that this result obey a law in chemistry. Because the reason why I had to put my own as definite proportion, because that's what we are working on. So you already know that. If it is jam, they can say show that, or calculate. If it is jam, they can say calculate the percentage composition of copper in these samples, or calculate the percentage composition of oxygen in these samples. Then you calculate to check the options. But if it is jam, if it is WAEC, you still have to solve it. You understand? You still have to solve all these things to be able to get your answer. So this is the question. 3 samples of copper 2 oxide was prepared. One, by adding concentrated triazonitrate 5 acid and heating the solution formed to dryness. 2, heating strongly the mixture of copper tetraoxosulfate 6 solution and sodium hydroxide. 3, by heating copper triazocarbonate 4 to dryness. So and they have given us the analysis. So do this. Use the comment box section to tell me what your answer is. What is the percentage composition in the first sample, second sample, third sample of copper, of oxygen in the first sample, in the second sample, and the third sample? I want to see your answer in the comment box section. So use the comment box section to actually show what your answer is, so that I can see it and see if it is correct and try to correct you if it is not correct. So I will stop here for today. In my other video, I'm going to treat law of multiple proportion, another wonderful law of chemical combination, and I'll treat law of reciprocal. In fact, a lot of textbooks did not even talk about law of reciprocal. They just stated the law and they left it. So in the next video, expect law of multiple proportion, which is the third one we are going to be looking in the next video, and law of reciprocal. Nice law, interesting law, and they are very, very educative, and these are laws that govern. So for these two other, I'm going to do another video to explain them, but I want to believe you understood law of conservation of mass and you understood law of definite proportion. So stay tuned to this channel. If you have not subscribed to this YouTube channel, kindly subscribe to this channel and turn on the notification bell so that you would be notified when I drop this other two videos. So till we meet again, do this assignment. I want to see your answer. I love you guys. Subscribe to this channel, like the video, share the video, use the comment box section to tell me what your answer is, and I'm going to see you in the next video. Thank you and God bless you. This is Chemistry Hangout. Thank you so much. God bless you.